here, if what I'm going to do, I'm going to traverse my graph from a starting node. Let's say that node is 0 or 1 or 2 or 3. It can be anything. So what traversal means, if I'm starting from 1, cover all the nodes, print all the nodes that can be reached from the starting node. Let's say what I'm going to print, I'm going to, from 1 we can go to 0, 4, 5, 6, 7, or 2, 3, to any node. So what I'm going to do, I'm going to print all the nodes, starting from 1. Okay, but there should be some systematic manner in which we should print, or we cannot print the random order. Although if you want to, I mean, there should be some systematic way in which we can print these values. Okay, then otherwise you are going to, if let's say there is a loop or something here, and you are going to stuck in that loop. So for removing that conditions, we are given with the BFS and DFS traversal. What it means, it means that starting from this node, print all the nodes that you can reach from here. Okay, so first I'm going to discuss about the DFS traversal. What a DFS traversal is, let's say a DFS means depth first search. It is going to go into the depth first, then it is going to come, and it is going to call, means let's say it is going to, I'm starting from my DFS traversal from here. So what it means, it is saying first go in depth and depth. First print me, go in depth, print 1, go in depth, print 2, go in depth, print 3. Then again come, then again go to 4, 5, then 6, then 7, or it can be anything. It means the other one will be the BFS traversal, that will be the level wise. How it is going to be in the level wise? It is going to print this level first, then this level, then 2, 4, then 3, 5, then 6, 7. But in DFS, what I'm saying, first print in the depth, it can be 0, 1, 4, 5, 7, then 6, then 2, 3. It can be 0, 1, 2, 3, then 4, 5, 6, then 7. It can be 0, 1, 2, 3, 4, 5, 7, then 6. It means where you're if you're printing something, go keep on printing until you reach a null value. Okay, until there is no connected node to this, means to these nodes. Okay, does the DFS traversal is clear with everyone, or do I need to repeat it again? The concept of DFS traversal, it means go in the depth first. Let's say, okay, Yudhishthir is saying it is clear. Let's say it is having one more node here. Let's say it is having 10 here. So how I'm going to do this in the DFS? First, I'm going to complete this. Then I'm going to come back to this node. So from 0, if I'm going to start to 1, I'm going to 2, 3. Then I'll come to 4, 5, and 6, and 7. Then I'm going to go print the 10. So first, I'm going to in the depth first. And then in the breadth first search, what it means? It means discover all the nodes that are in this level. So from 0, it will go to 1 and 10, 2, 4, 3, 5, and 6, 7. It is going to print in the level order. Okay. Is it clear now? Or do anybody is having any doubt? If you are having, you can ask right now. If it is clear, then I can move to the coding part of DFS Traversal. What do you want? I should be doing it using map or using matrix, or both. What do you all want? Both. Okay, you're stressing both. So first, let's start with the, if we want to do the both. Okay, stressing map. Let's do with the first with matrix, and then we'll come back to our map again. Let's create another code for that. What we are going to do? Let's create those nodes again. That graph. Just 1 minute again. The concept should be clear. If the concept is clear, you can do with the help of both. Okay, do not open. Okay, just wait a minute. Okay, 1 second, everyone. I don't know what is going. I have to cut my screen. Okay, the going to share my screen again. So what I'm doing here, I'm going to create a matrix representation of our graph quickly, so that okay, the graph I have lost. Okay, so we fine. So what we are going to do, we are going to create a matrix representation of our graph. Let's quickly code it because we have already discussed that. So let's say matrix of 6 by 6. Again, I'm going to create a matrix of 6 by 6. I'm going to use a main-set function that is going to fill my matrix with the zeros and the size of that mat. Create an add edge function. Let's say that the graph was having from 0 to 1, add edge from 1 to 2, add edge from 2 to 3. It was something like 2 to 3. Right. It was from 1 to 4 as well. Add edge from 1 to 4. I'm going to do for that graph only. I'll create that graph again, don't worry. Add edge 1 to 4, 4 to it was 4 to 5 and 5 to 6 and 5 to 7. Yes, 4 to 5. Add edge 5 to 6. Add edge 6 to 7. Sorry, it was 5 to 7. Yes. So I'm not going to print my matrix. I'm just directly going to use my DFS Traversal to print all the data in the matrix. So what I'm going to do, I'm going to call my DFS function. Okay, we'll create DFS later. Let's create an add edge function first. It will have the return type as void add edge. It will have an integer matrix of size 6 by 6 int st int nd and I equals to true. So what you are writing in that day, mat of starting and end is equal to 1. If pi is equal to true, mat of end as from starting is equal to 1 again. Okay, so our add is function is fine now. So we can move with the DFS traversal. Okay, let's print our okay. I don't think there is a need of printing or matrix because we have already discussed that. So how I'm going to I have to print first because I have to explain that function as well. So what I'm going to do, I'm going to print my graph quickly. Okay, let's see, it is having 6 by 6. What I'm having here, 99 is n is equal to 6. Let's say, and what I'm writing here, I'm giving 2 spaces because we are going to print my column numbers first. See out I spaces. And what I'm printing here, empty I equal to 0, I is less than n, I plus plus. See out my I and the space here. Sorry, it is my I and the spaces as well. Okay, for int j equals to 0, this I is going to print the row numbers. Okay, so I j is equal to 0, j is less than 1, j is less than n, j plus plus. What I'm going to print here, see out mat I at of ij and spaces here, and I'm going to change my line after each. Okay, yes, you have to pass. Okay, we have not passed our function. We are going to pass it. Thank you, Shrey. Okay, we have changed the line here, and what Shrey has mentioned, yes, we have to pass on matrix as well because we are doing functional programming, not the object-oriented programming. Okay, so my matrix, let's see, I've entered my matrix here. Okay, fine. Let's call our print function and let's pass our matrix from it. see whether we are getting the correct output or not. We should be getting our output. Okay, we have not changed our line here after printing the column numbers. We should be changing our line here. Okay, so we are getting our matrix representation here from 0 to 0, 1, 2, 3, 4, 5, and from 0, 1, 2, 3, 4, 5. Oh, we have to give our size as if it is having from 0 to 7, so it should be the size of our matrix should be the 8, not 6. Okay, so here I should be writing 8, and here it should be 8 as well, and here as well it should be 8. Okay, let's see whether we are getting the output correct or not. It should be 0 to 7. Yes, we are getting our correct output. Sir, there are 0 to 7. Okay. Sir, we have to pass matrix. Okay, thank you, Smith. Thank you, Shay. We have printed our matrix. As we can see, we have wasted a lot of memory here, although we have to learn the matrix representation. So we are going to quickly we are going to discuss about the DFS traversal. As let me quickly create the graph again, draw the graph again, so that we can discuss. Let's say it was 0, it was 1, it was 2, and it was 3 here. Okay, let's say it is 3, it is 4, it is 5, and this one is having 2 childs. Although in the case of graph we don't call it child, but for our convenience we are saying for from 5 to 6 and 7 we are having edges. Okay, so is it fine now? The same graph I have drawn again. So how we are going to discuss? First we are going to pass to our DFS function. First we are going to pass our starting node. Let's say I want to start my DFS traversal from node 0. So what it should do, my DFS traversal, what it should do, it should just print 0, and it should say that from 1, from 0, pass my DFS traversal, function, means for all the nodes that are being correct, that is being attached with this 0 node. Okay, so what I'm going to do, I'm going to just print this function, and I'm going to check whether what are the nodes that are connected directly to this function, directly to this node. I'm going to call my DFS function for all those nodes. Again, I'm going to print this, and again I'm going to call these nodes. So what it will do, it will just first, for it will print 0, and it is going to call uh, DFS function again for all the nodes that is being attached with this node. So from 0 only one node is attached, that is 1. So what it is going to do, from 1 it is going to print 1, and again what it will say, it will say that call this function for 2 and 4, but it will call this function for 2. Again it will going to print 2, so it is going to call this function for 3. So once this graph will be, this part will be printed, then again it is going to come to 4, because we are doing the recursion. First it is going to complete its stack, then it is going to execute this. So again the 4 will be called, it is going to print, then it will be called for 5, then 5 will be printed, and it will call for 6 and 7, then first 6 will be printed, then 7 will be printed. So how this is going to print? 0, 1, 2, 3, 4, 5, 6, and 7, means it should be sorted from 0 to 7. Okay, so what we are going to do here, we are going to add an visited means array here. Why? Let's say what I'm having here, let's say from 7 to, let's say from 7 to 4 we are having another node. We are having a cycle here in this, or in this graph. So when it is going to call for 4 to 5, it is going of, first it is going to call for 4 and the 7 as well. Then 5 and 7 is, 5 is going to print, and 5 is going to call for 6 and 7 again. So 5 is going to call for 7, 7 is going to call for 4, it is going to call for 5. So it is going to get in an infinite loop. So what we are going to do, we are going to create a widgeted array. What this widgeted array will store, it is going to store what the data we are printing, it is going to means update that it has already printed, so do not need to don't call for this node again and again. Okay, so what we are having, let's say I'm creating a boolean array. What boolean array will do, let's say this is our visited array of size 8. The starting it is having value as false false false, because it can have the value visited is the type of bool array, so it can have the data false, either false or true. So in the starting all the nodes are false, it means there is no node that has been visited already. So what I'm saying, call my DFS function now. Let's say I'm creating a DFS function. I'm giving my matrix to him, and I'm saying I'm giving him my visited array as well, and I'm passing my start, let's say start node from where you should start the traversal. So what I'm saying, void DFS, it is not going to return anything, it is just going to print something. So its return type would be void. So I'm saying it should take an array that is mat 2D array of type size 8 by 8 int, and the other one is bool visited of size 8, as well as it is taking a start pointer from where we should be starting. So what it is going to say, first print start given space, and what you do, you just do update that visited of st as true. It means st is being printed. And now what I'm going to do, I'm going to say for int I is equal to 0, I'm going to check whether for means for which are the nodes that is directly being connected to st. So int I is equal to I less than 8 I plus plus. Now we are going to check whether which are the nodes that is directly connected to st. So I'm going to check empty of st and I. If empty of sti is true, means if it is 1, it means if it is 1, it means that there exists a path from st to I. And what I'm going to check if visited of I is not true. Either you can write is not true, either you can write if it is not true. Then if I'm saying if there exists a path from st to I and I has not visited it, so what you need to do, call my DFS function for that node. And what you need to do, I'm giving my matrix again. I'm saying give the visited, uh, passing my updated visited, as well as I'm passing into the st, I'm passing my I. Okay, so it will keep on calling for each and every node that is directly connected to node start, and it is going to check first whether this node has been already visited or not. So let's say in this case what will happen, so 4 is going to call for 5 and 7. So for 5 and 7, if it is calling for 5 and 7, so 5 it will come for 5, so 5 will be printed, sorry, yes, 5 will be printed, and it is going to call for 7. And again if the 7 will be printed, it is going to call for it is going to update the visited as true. So if 4 is going to call 7 again, it will check whether it is visited or not. It is going to return a false, because it is visited and a not is there, so it is going to return a false. So it is not going to call a function for 7 again, so will not stuck in the while loop or infinite loop. Is it fine? Let's see whether we are getting the correct output or not. I should be writing here that DFS Traversal. Okay, let's see whether we are getting the correct output. I hope everything is fine. So we are getting 0, 1, 2, 3, 4, 5, 6, and 7. Yes, it means we are getting the correct output. Let's change our start pointer. Let's change it to 1. So from 1, where it should go first? Either if it is going to 0, it is going to print 0. Then it is going to come 2 or 3. Either it can go to 0, 2, and 4. If it is going to 0, it is not going. It is going to print 0 as it is. So 1, 0. and if it has two options again, either it can go to 2, either it can go to 4, because it is I is starting from less to more, so it is going to print 2 first. If it is going to print 2, it is going to print its depth first. So 1 0 2 3, then again it is going to come 4 5 6 and 7. 4 5 6 and 7. So we have not added this edge, so I'm going to remove it. So how a DFS traversal should look like now? 1 0 2 3 4 5 6 and 7. Let's run it. Let's see whether we are getting the correct output or not. It should be 1 0 2 3 4 6 7 4 5 6 7. 1 0 2 3 4 5 6 7. Once to a DFS function. Okay, this time I'm showing the DFS function. Rest for everyone, it is clear, or do I need to repeat it again? The DFS function. If the DFS function is clear for the matrix representation, it will not be tough for the that map representation. We are going to do it in very quick manner. Just check once if it is clear or not. Just give me your responses. If it is not clear, you can ask me right now. I'm going to repeat it again. Don't worry. Waiting for your responses again. Is it clear or not? When st is equal to 3, what happens? Was okay. So Yudhishthir is asking, when st is equal to 3, what is going to happen? So for st is equal to 3, it means 2 has already been printed. For st is equal to 3, it is going to say that it is going to print st first, and it is going to mark the visited of st as true, and it is saying from I from 0 to 8 run a loop. So st of I is equal to 1. From st, it means 3. From 3, where we can go? From 3, from 3 0 3 1, we cannot go to, from 3 to 0, we cannot go from 3 to 1. Yes, we can go from 3 to 2, but it is again going to check whether 2 is being visited or not. It is going to say that 2 is being visited because 2 has already printed. So what it is going to say, do not do anything. So again, it is going to check for 3 3 3 4 3 5 3 6 3 7. There does not exist any path, so it is not going to do anything. It is just going to return back to 2. Again for 2, let's say it has called this function for 3, and it is going to check for 4 5 6 and 7. For 2 to 4 5 6 and 7, there does not exist any path, so again it is going to return to 1. Okay, then if what is our starting node? Is it 1? So again it is going to come to 4, because for 1 to 2, we have called a function. 1 to 3, there does not exist any paths, so it is going to come to 1 to 4. Okay, is it clear in this step? Smith is saying, sir, this condition map st of I is equal to 1. I did not got it. Can you say what it? Okay, what it means, map of st of I is equal to 1. Smith, we have already discussed that for which nodes it is going to call the recursive call. It is going to call its function. Let's say my starting node is 0. So it is going to check, it is going to call for 1. So first it is going to check, because we are using our matrix representation, it is going to check whether from 0 to 1 there exists a path or not. So it is going to check from 0 to 0, because our loop is calling from 0 to 8, 0 to less than 8, from 0 to 7. It means st, it means 0 0 0 1 0 2 0 3 0 5 0 6 0 7. So if 0 0, it will say no. From 0 1, it is going to say yes, there exists a path. So it is going to check whether 1 is being visited or not. If it is not visited, it is saying that call this function again. Okay, I hope now it is clear for everyone. So now we are going to discuss about the DFS traversal using